Hi, my name is Dr. Phillips and I'm here with my lab partner, Micheal, and we're demonstrating our project, which is a multi-purpose musical instrument, which is a combination of a theremin and a drum sequencer. A theremin is a musical instrument that outputs a sine wave based on the distance of an object from a sensor. In this case, our object is an ultrasonic sensor, and the object that it's measuring is a hand. So it measures the distance from a hand and outputs the pitch and changes the pitch of an output sine wave based on the distance of a hand from the sensor. A drum sequencer is a device which takes a pattern and plays it back, playing a rhythmic pattern, and plays it back, playing a different note for every measure, every beat of the pattern that's being stored.
To demo this device, the theremin sounds like this. With maximum ranges up here and down here. The drum sequencer works off of this LED and this green button. When pressing this green button, an LED shows up, which makes a drum beat sound from the speaker. This beat is a cyclical beat, which means that every 8 beats it will repeat itself. These sounds can be combined to sound something like this.
Talk a little bit about the theory of operation behind the drum sequencer. So the drum sequencer code is based around the manipulation and output of an 8-bit register, which stores the rhythmic pattern that we want to output. So this, on the code side, all the manipulation of that and the displaying on this LED takes place on the code. In addition, we have some hardware that we call a drum voice, and 505 style drum voice, that creates an output of a decaying sine wave when a small pulse is pushed into that from the board. Which allows us to play back and make a nice sound for our drum sequencer. For the hardware there, we have an op amp, 2 resistors, and 2 capacitors that creates that decaying sine wave when a brief pulse is pushed into it. And for this op amp, in addition, an interesting engineering challenge we had was that op amp needed a positive and a negative voltage supply, which couldn't be supplied by our board. And so what we did is we have a battery pack inside of in this enclosure here, that is divided across a voltage divider, splitting the voltage up into a positive and a negative 3-volt power supply, which can then be supplied to the op amp in order to create the decaying sine wave. Most of the code for our drum sequencer is handled in the SysTick interrupt, which is configured to run every 500 milliseconds. In this code, we have logic for a pseudo debouncer, which makes it so our code can only accept an input every 500 milliseconds. In addition, a circular bit shift operation, which is performed on the code every 500 milliseconds, and code that handles the output of a small pulse whenever the leftmost bit of the drum sequencer is toggled on. And in addition to this, in our main function of our code that's looping forever, we have code that displays the current value of our drum track to the LED here, and it detects a button press whenever we hit the button, and changes the leftmost value of our drum sequencer.
The theremin works off of an ultrasonic sensor, as shown here. The ultrasonic sensor has 2 cylinders, one of which outputs a frequency, a sound, and the other one receives that sound back. It's powered based off of 5 volts, also connected to ground, and has 2 pins. One's an input and one's an output. The speaker will output a 10 microsecond pulse of high frequency noise that we will not be able to hear, which then propagates through the air until it collides with an object above the sensor. This will then send the sound waves back, which will be received by the microphone. The microphone then sends a pulse to the microcontroller with the duration that the sound wave was in the air. So if the sound wave was in the air for a second, the microphone would send a second long pulse to the microcontroller. This pulse duration can then be used to calculate the actual distance. We used the speed of sound in air, which is 34,300 centimeters per second. We then use this divided by 2, because it has to travel the distance twice, to find the exact distance of the hand from the sensor. This is then used, the distance, to set up a PWM, a pulse width modified signal. This can be treated as a sine wave if you use a dampener, and that is sent through one of the GPIO pins to the speaker, which then outputs that as sound. With the theremin outputting a sound and the drum synthesizer also sending out a sound, there was need of some sort of combination of the two, a way to combine them. This was done using a summer, which was 500K resistor for the ultrasonic sensor, the PWM outputted from that, and a 2K resistor from the drum synthesizer. This was then all combined using an op amp and sent to the speaker. All of this was combined and put into this housing right here. Because there were a lot of wires and a lot of connections and hardware, we didn't want it to look all cluttered. So we designed this simple, minimal enclosure consisting of this main box in which most of the hardware is contained, mid plate, which we will talk about in a second, and a top plate to cover everything that's not necessary. The only things that we needed to access outside were the speaker, the LED, the button, and the sensor.
In the original plans for our drum sequencer, we wanted to have multiple tracks on the drum sequencer that could be selected and each edited individually. These tracks would each have a different voice, creating a different type of decaying sine wave to have a different sound. In this way, you could create much more interesting sounds and modify them all through the use of just 3 buttons. In the end, this design idea had to be scrapped because of the limited hardware space that we had available inside of this box here. While the individual components did not require a large amount of space, as most of the drum voices would just be made up of an op amp, 2 resistors, and 2 capacitors, the problem that we had was that each of these different connections would require multiple connections to the board, creating a lot of wiring and taking up a lot of space inside of our enclosure. Because of this, we just decided to simplify to 1 track. But in the future, if we were to bring this thing to production, you could print our hardware on a PCB, which would greatly reduce the amount of space required inside of the enclosure and allow you to add multiple drum voices and tracks.
One of the major problems we encountered when working with the Theremin was the accuracy of the sensor we had. As you could hear in the demo earlier, even with a stationary hand, the pitch varied a little bit. This we tried to troubleshoot in software, but we came to the conclusion that our distance sensor right here was not accurate enough. Because of the frequency of sound that we were using, the wavelength varied enough that we couldn't get an accurate enough measurement. In the future, if we wanted to remedy this issue, we could have purchased a LiDAR sensor or something with a smaller wavelength. The downsides of this is cost, something that we wanted to avoid. So we decided that the ultrasonic sensor had an accuracy that we were good enough with. Another issue we encountered was with printing the housing we have here. When printing, the mid plate that we were supposed to use had a printing error. You'll notice right here in the center, this hole was originally misformed, more than it was right now. We had to try to use a heat gun and melt the plastic back into place, but this ended up deforming it more. We ended up able to get around this with just using tape. Because we cannot see the inside of this, we just taped everything up to the top of the top plate. This allowed for everything to still be modular and allowed more space for the connector pins to all the connections down there to fit easier.
In conclusion, our project was a definite success, but we faced our fair share of engineering challenges, some of which caused us to change the scope of our project. The main 2 scope changes that we encountered were originally having multiple tracks on the drum sequencer and simplifying it down to just having 1 track. In addition, we had also planned to have 2 ultrasonic sensors for our Theremin, one of which modified the pitch of the output and the other which modified the volume and the magnitude of that sine wave. Because of design complexity, we ended up simplifying to just have 1 ultrasonic sensor which controls the pitch, but the volume can still be modified through our system by the use of the speaker and the internal volume built into that.